When a curve is normal, it will always follow the same pattern. The two standard deviations closest to the center will contain 68% of all data. If you include the four closest standard deviations, it contains 95% of all data. The more standard deviations from the data, the rarer a result is. This is useful when trying to figure out the best scenario in this situation.
Variability is the way scores are placed, whether that is close together or spread out, which then leads to high variability and low variability. High variability is when scores are really spread out. Low variability is when scores are clustered together.
Standard deviation is a measure of how spread out your data is. This is used when you have a standard bell curve, and it's used to see if a specific data point is standard or unusual. If your data has a high standard deviation, that means that your data is going to be spread out, as in scenario 2. If your data has a low standard deviation, that means that your data will be close together, as in scenario 3. Standard deviation is notated as a lowercase Greek letter sigma, and the formula for standard deviation in a sample is the square root of the sum of x minus the mean squared, where x is your measurement, divided by n minus 1, where n is your number of data points, and minus 1 accounts for bias.
The problem was that your score on the first exam was an 87, based on the following scenarios, which would give you the highest score on the exam as compared to everyone else who took the exam. Our answer was the third scenario.
Scenario 3 is the scenario where your score would be considered a high score compared to others. The standard deviation is 1, meaning most scores differ from the mean, which is 84, by 1. Your score differs from the mean by 3, which is a high deviation as compared to other students in the class. This puts your score on a rare high end of the data, making your score one of the highest as compared to other students' performance.